Hi Year 11, this is Booklet C Part 2. I'm going to keep the noise down a little bit on this, so listen up carefully because my children are in bed. I don't want to wake them up. So we're going to look at starting this one with construction and loci. We're going to then look at some transformations and some exterior and interior angles, and hopefully then this will take you to the end of that booklet. Now there's a bit of an explanation here, but if we go to some plain paper, there are a few types of construction that you're going to have to be happy with. So for example, let's start with this one. If the question said, that's point A, okay, it's gone out of focus, it should come back in, there we go. If the question said, shade in everything within 5 centimetres of A, okay, I'd get my ruler, open my compass to 5 centimetres, okay, circle all the way around, apologies, can't do that like that. Okay, and anything inside that circle is within 5 centimetres of A. Anything outside that circle is outside 5 centimetres of A. An alternative to that, possibly the question will ask you to bisect an angle. Let's draw an angle. To cut an angle in half. You should be familiar with this one. Should be happy with it. Okay, I get my compass again, open it maybe to a couple of centimetres and start with an arc there, then take the stabby bit and put it on that intersection there, and then move it to this intersection here, and it gives me that kind of look, and I connect where these two lines cross to the angle, and in so doing I am bisecting, cutting that angle in half. Now let's remind ourselves about a perpendicular bisector, bisecting a line. Okay, actually before I do, maybe I'll make this point. If we call these points A, B and C, okay, anything above this line is nearer to the line AB. Anything below this line is nearer to the line AC. Okay, as I said, moving on, and you should be familiar with, let's draw a perpendicular bisector. Okay, compass open past halfway, anywhere past halfway, so that I get this overlap when I draw my two arcs above and below the line. Connect that intersection to that intersection. Again, in the context of a loci question, okay, for following some rules, if I call that point A and point B, anything to the left of this is nearer to point A, anything to the right is nearer to point B. Now, the only other thing that they may ask you to do is to construct some angles. I'm going to do the 30-degree angle for you. Okay, so let's start with a small line there. And in fact, let's start with a 60-degree angle. To construct a 60-degree angle, I'll put the sharp point at one end of the line and open the pencil all the way to the other end of the line and draw an arc only above the line, like that. Then I do the same from the opposite direction. An arc coming down like that. Apologies, it's quite faint. Let me just go over that a little bit more. But the important point is there, where those two arcs intersect. If you connect that point to both ends of the line, what we've constructed is an equilateral triangle. So the angles in here are 60, 60 and 60. So if we have to construct a 60-degree angle, that's how we do it. Sharp point to pencil, either end of the line, arc that way, and connect it up. Now they may ask for the 60-degree angle this side or this side, but if we draw both sides, then we know we kind of tick all the boxes. Now, assuming that we've already constructed the 60, if they ask for a 30 degree angle, well, all we've got to do is take the 60-degree angle and bisect it like we did here. Okay, so let's say they would like a 30-degree angle at the point A, and point A was here. I get my compass, open it to a couple of centimetres, sharp point there, arc, okay, from here, an arc that way, and from here, an arc that way, like we're bisecting the angle, and connect that corner straight through, and in so doing, split that 60 into 30, 30. Right, let's see these in some exam questions. And we're into Booklet C. We're opening up to page 9. Okay, and this question, we've got to shade in an area above the line, okay, and the region that we've got to shade in is such that the point P is nearer to point A than point B. So to help me with that, okay, here's A, here's B. What I've done is using that arc and that arc, I've drawn my perpendicular bisector. But if I need to be nearer to point A, I want to be this side of the perpendicular bisector. Second condition, angle BAP is less than 60 degrees. Now in order to do that, I need to draw a 60-degree angle. So I don't know how well you can see it, but what I've done is put my sharp point there, open to there, and drawn, highlight this in red, and drawn an arc that would go round here and comes like that. Then gone from the other side, open to there, and drawn an arc that comes around like that. And by connecting that to there, what I've created here is an equilateral triangle. So this angle now is 60 degrees. However, the condition is that the angle needs to be less than 60 degrees. So I'm looking for points beneath that line, less than 60 degrees. So to the left of this line and underneath that 60-degree angle there. My final condition is that the distance from A to this point P, wherever it is greater than 6 centimetres. So for this one, I'm actually going to do it for you. I'm going to open my compass to 6 centimetres, put the sharp point at A, and draw myself a 6 centimetre circle around A. Now, anything inside that circle is within 6 centimetres of the point A, but anything outside that circle is more than 6 centimetres away from A, okay? So where on this diagram am I to the left of this line, beneath this line, but outside this circle? The only point where those conditions are all met are in this region here. Okay, the question that I've added at the bottom of the page, just so again, to make sure you're happy with it, is to construct a 30-degree angle. I've started by constructing a 60-degree angle with a full arc up there, made my equilateral triangle, and then cut those in half, like I did on my instructional video at the start. And the next one. This time I'm looking to bisect the line. No, I'm not. I'm looking to draw a perpendicular that isn't a bisector, because it won't cut the line in half, but it goes perpendicular from here. So a slight variation on the perpendicular bisector. What I'd probably be doing here is putting the sharp point there and opening to the point P to draw that arc, and then put the sharp point there and extend this slightly further so that I'm on point P again-ish, and drawing that arc. And if I connect those up, I've got a perpendicular which runs through the point P to the one at the bottom of the page. Okay, we've got to shade in the region where all the points are nearer to AC, nearer to this line than this line. In order to do that, I've done an angle bisector using that arc, and that arc. Okay, line straight through, but I need to be nearer to AC than AB, so above that line. But it also tells me that the points are less than 6 centimetres from B. So I've opened my compass up to 6 centimetres and drawn myself a circle around B. And I know to be less than 6 centimetres from B, I've got to stay inside that circle. So I'm asking myself the question, where am I that side of that line, but inside this circle? And the region that satisfies that is that there. On to page 11. Okay. I'm actually going to do this as a tutorial in class, so I'll leave this one. Okay, we're going to construct a 45-degree angle, but to give you a bit of a heads up on it, okay, a 45-degree angle is half of a 90-degree angle. So all I'd have to do is construct the 90 and then do an angle bisector to get 45. That is how I make a 90-degree angle. Okay, and then I would do an angle bisector, an arc there, then one there, and a line through, and then by cutting that 90 in half by doing an angle bisector, I'm making 45. So hopefully that can kind of give you a clue as to get started on that one. But the final one here looks awkward. I have finished it, but just to show you what I've done, it says shade the region where the points are less than 5 centimetres from X. So this time a circle around X, a 5 centimetre circle. Do I need inside or outside the circle? The points are less than 5 centimetres from X, so inside that circle, which is what these arrows are showing here. Okay, the points are nearer to Y than to X. Well, in order to show that, I need a perpendicular bisector. Okay, and if you can see it, the arcs for that, the important bits are there, 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 and there. Okay, I've opened my compass past halfway, drawn that and that. And to be nearer to Y than X, I need to stay this side of that line. Okay, shown there. So where am I to the right of that line, but within that circle, where that is shaded red? Okay, on to some transformations. Give you a kind of brief talk through all these, okay? The first one here asks us to enlarge the triangle by a scale factor of -2. Forget the minus a minute. What does the scale factor of 2 mean? The scale factor of 2 means I need to draw this shape twice as big and twice as far away from the centre of enlargement, which here is the origin. So if the scale factor was 2, I'd start at the origin, I'd count how I get from the origin to maybe one of these sides, and I'd double it in the same direction. Then I draw the same shape but twice as big, so it ends up being twice as big and twice as far away. By putting a minus before the 2, suggests that not only does it have to be twice as big and twice as far away, but also in the opposite direction. So to get from the origin to here, I'm going right and up. To get from the origin to my new shape, I need to go left and down. Let's just take one point. To get to this point, it's 1 right and 2 up. Twice as far would be 2 right and 4 up, but because it's minus, it's 2 left and 4 down. This point here, instead of going 3 right, 2 up, is 6 left and 4 down, and so on. The next one, for a rotation, I'm going to use tracing paper. I'm going to trace the shape. I'm going to trace the centre of rotation, which they've told me is -2, 3 there. You'll also notice I put a little north line on there to show that when I'm tracing this and I turn my tracing paper, I can see when to stop. And I'm turning anti-clockwise 90 degrees. And if you trace that and put your pen on there and turn, you'll see that that will move up and arrive here. Next question. A scale factor of half. Well, if a scale factor of 2 is twice as big and twice as far away, a scale factor of half is half as big and half as far away. So to get from here to here is 8 to the left and 2 down. Half as far away would be 4 to the left and 1 down. And then this new triangle is half as big. Again, if this had been -half, I would have gone half as big, half as far away, but in the opposite direction. So this would have ended up being up here. So instead of 4 left and 1 down, 4 right and 1 up. And do that for every single point. Another enlargement, scale factor half. Again, using the origin as the centre of enlargement, this shape is half as far away from the origin. Instead of 6 across 6 up, this point is 3 across 3 up, and then half as big, half as big, half as far away. Reflect the triangle shown in the line y equals -1. We've got to be confident here knowing how to draw y equals -1. Y equals -1 is there, so this is a horizontal line through y equals -1, and then I've reflected the triangle from above to below, and you can see that it is flipped. Okay, if this had been x equals -1, I would have found where x is -1 and drawn the vertical line through that. What about a translation? Translation 4 to the left and 2 down. Now, another way of writing this is to give you the translation vector like that, where the top number tells you left or right and the bottom number tells you up or down. So 4 to the left would have been a -4, and 2 down would have been a -2. But they've made it a bit easier than that. They've actually described it. So I take a point and I move it 4 to the left and 2 down, and then I draw an absolute replica of the shape, but in its new position. Okay, no flip, no rotation, not any bigger. The same shape, same size, not flipped, not rotated, just in a new position. Okay, another rotation here. Okay, again, I'm not going to do this one, but get your tracing paper. Find the centre of rotation, -1, 2, which is there, maybe with a north line. Trace this, put your pen on top of the tracing paper at this point, and turn this time clockwise, and the shape is going to come down here at some place. Describe fully the transformation that maps triangle ABC onto this one. Well, hopefully you can see it hasn't rotated, it's no bigger, no smaller, but it also hasn't moved. What's happened is it's flipped. Okay, but it's probably not enough here to say reflection. If I say it's a reflection, I'm also going to have to give the line of reflection, which is going to be halfway between, which looks to be there. Okay, so my line of reflection, my mirror line, is y equals 1. Unfortunately, this question's made it in twice, so it's a replica of what we did on the last page, so nothing to say about that. Scale factor -1/2 enlargement, so half as big, half as far away, but in the opposite direction. So instead of 2 right and 2 up, it would be 1 right and 1 up, but because it's -1/2, it's 1 left and 1 down, and you can see my notes there, half as big, half as far away, in the opposite direction. Okay, here I'm being asked to describe another transformation. Now I can clearly see if I'm going from A to B, B is twice the size of A, so I'm going to get a mark for saying this is an enlargement. But if it's an enlargement, I want to know how much bigger or smaller it is. Well, because we're going from A to B, the scale factor is 2. If we were mapping B onto A, we're getting smaller, so I'd say the scale factor is 1/2, okay? That would be your second mark. But you also need to give the centre of enlargement, and that'll involve drawing the rays that connect the equivalent points, and they'll go through a certain point. Now, this is slightly out, okay? If this hadn't been shrunk by myself on this page, you'd have found that that point was here at the coordinate 2, 3, all right? Because I've shrunk this to fit it on the page, it's kind of distorted it and made it sort of miss that point, but don't worry about that, okay? And finally in these, all right, a reflection in the line y equals -x. The line y equals x would suggest that when y is 1, x is 1. When y is 2, x is 2, and so on. So it would run diagonally this way. Okay. Whereas the line y equals -x, when y is 1, x is -1. When y is 2, x is -2. When y is 3, x is -3. So it runs the other way. Now it's quite nasty to kind of reflect these, because you're actually not, rather than counting vertically or horizontally, you're counting diagonally. So I've gone 1, 2, 3 diagonally there, 1, 2, 3 the other side, 1, 2, 3, 4 diagonally there, 1, 2, 3, 4 the other side, okay? And that's the end of that. And quickly for a minute, just to end this, take you back to the front, into this idea of angles in polygons. And all I want to tell you here is exterior angles add up to 360 degrees. So if I'm asked a question, what is the exterior angle of a regular pentagon? 360 divided by 5, 72 degrees. What is the interior angle of a regular octagon? Well, I can't tell you the interior, but what I can tell you is the exterior is 360 divided by 8, which is 45 degrees. However, an exterior and interior will add up to 180, so the interior is 180 take away 45, which is 135 degrees. If a regular shape has a 162 degree interior angle, how many sides does it have? Don't know. But if the interior angle is 162, the exterior is 18. 360 divided by 18 tells me that this is a 20-sided shape. Okay, I'm going to leave that video there because we're coming to the end of the life on my video camera. There are a couple of others for you to look at there. Again, I'll go over those in class, but hopefully this brings this booklet to a nice end for you.